Okay, class, this is Mr. Contreras. I am here to do a lecture over 12.1, derivatives. Okay, I decided to start with chapter 12 because I knew I wouldn't have time to hit 11, okay? I really want to help y'all with this, so I'm going to start with chapter 12. It's okay to show you how to do these types of problems, okay? All right, so chapter 12, 12.1, derivatives. Okay. Excuse me, class. Let's see here. Okay. Let me get out of this thing. I am having some technical difficulty with this. Let me get out of this. And that should work right there. Okay, so I want... Okay, so let's see if I go to the next slide here. Will it go to the next slide? Okay. No, it will not go to the next slide. All right, excuse me, class. So let me go on and okay. So let me get started. I apologize for that. It's not working properly like it should. All right. Okay. So in derivatives, we got this first rule called the constant rule, okay? It says if f of x is equal to k, where k is any real number, then the derivative of a constant is 0. Okay, so for example, so anytime I'm taking a derivative of a constant, okay? Anytime I'm taking a derivative of a constant, see, a constant is a line, right? Okay. When you're finding a derivative, you're finding the slope of the line, okay? So when I'm finding the derivative I am finding the slope of every point of the line. Okay? All right? So let me just put it to you this way. Look at, so I can pick any point on this line. Okay? What's the slope of a horizontal line? The slope of a horizontal line is 0. So this horizontal line goes through all these points, right? So therefore, if I find a derivative of this whole line, okay, that equation that I find will give me the slope at each point. Okay? So therefore, the slope at every point here is 0. Okay? The point at every slope at the slope at every point is 0. Why? Because what's the slope of a horizontal line? The slope of a horizontal line is 0, right? Is this slope increasing or decreasing? Excuse me. Is this line increasing or decreasing? No, right? It's a flat line. It has no slope. The slope is 0. So anytime I take the derivative of a line, of a flat line, of a constant, excuse me, okay, the derivative is 0. So therefore, the f prime of x is equal to 0, right? So if let's say, for example, if I plug in p, this point p here, right, that they have here shown, this point p. If I plug in p into that function, guess what my slope is going to be at that point? 0. If I plug in any of these points into my function, my derivative function, okay, what's my slope going to be? 0. It's always going to be 0 for a constant line, okay? All right, so let's go on. Okay, I'm going to go on. All right. So here's an example. Find the derivative of the function. Okay? Find the derivative of the function. So it says here, find the derivative of the function, and then we're going to use what you call the power rule. Okay, here's the power rule. It says if f of x is equal to x of n for any real number n, then the derivative of the function is equal to n times x to the n minus 1. Okay? So the derivative of f of x is equal to x and n is found by multiplying by the exponent n and the exponent of, excuse me. Okay. So the derivative of f of x equals x to the n is found by multiplying the exponent, is multiplying the exponent, or multiplying by the exponent n and decreasing the exponent on x by 1, okay? So let me give you a simple example. For example, let's say I have f of x is equal to x to the 5th, okay? I'm just looking at this one example. If I want to take a derivative, okay, of this equation here, I would have to use the power rule. The power rule says, take this number, drop it right here in front of the x. So it's going to be 5x, and then subtract 1 from that exponent. What's 5 minus 1? 4. Okay? Therefore, f prime of x is equal to 5x to the 4th. The prime means derivative, okay? This little symbol here means I took the derivative of the function. So that's what the power rule is saying, okay? All right? It is found by multiplying by the exponent n, okay? So my 5 is the exponent, right? I multiply by that 5, the whole function by that 5, and then decrease the exponent by 1. I subtract 1 from the exponent. This is what that power rule is saying, okay? So for example here, if I want to take the derivative of this function here that's given to me, okay, y is equal to, what do I do with the x cubed? I drop the 3 down, and I subtract 1 from the 3. What's 3 minus 1? 2. See that? Minus. Now you see that fraction right there? Don't let that fraction mess with you. Just put it to the side. Okay? All right? We got x squared. What are we going to do with that 2? We're going to drop that 2 down. So this is going to be, we're going to multiply this. So this 2 is going to be multiplied. Right? Oh boy. Let me see here. Let me erase that. No. Okay. All right. So I'll bring down that 2. Okay. This 2 is going to come down. It's going to be multiplied. Now there's an understood 1 here, okay? So that 2 is going to be multiplied to 1 over 52. So it's going to be 1 over 52 times 2 to the x, right? And I subtract 1 from the 2. What's 2 minus 1? It's a 1 here. Okay? So see what I did? Okay, I moved that 1 over 52 to the side, and I took the derivative of x squared. Derivative of x squared is 2x to the 1. I just dropped the 2 in front of the x, and I subtract 1 from the exponent, which is a 1. Okay? Plus, okay, what's the exponent of 16x? Okay? The exponent of x is 1. So therefore, I just go 1 times is 16, and then subtract 1 from x. Guess what that means? That's x to the 0. Okay? And then when you take the derivative, remember that from the last slide. The derivative of a constant is 0. Okay? The derivative of that 5 is 0. So then what do we have? We have y equals 3x squared minus 2 times 1 over 52 is just 2 over 52, okay? 2 over 52x. Now, because that exponent is a 1, you don't have to write the 1 here, okay? Plus, x to the 0, anything to the 0 is a 1. This goes to a 1, okay? So this right here just goes away. It just goes to a 1. Anything to the 0 is a 1. So what's 1 times 16? It's just 16. And that 0 we don't need to write because 0 is 0, right? This is your answer. And by the way, put a little prime there saying that we took the derivative, okay, of this function. So that's how you take the derivative of a function, okay? All right, next slide. So here are some more rules, okay, to go with what we've been looking at. We have the sum and difference rule. Let me clear the screen here. You have a sum and difference rule. And that's what we just did. The sum and difference, that means we had a sum or we're adding or subtracting many functions together, okay? All right? So we had the sum and difference rule. And in that sum and difference rule, we use the power rule to take the derivative, okay? That's what we did in that last slide, okay? Then we got another, so we got the sum and difference rule, okay? That means, all right, we have the power rule. Then we have the, okay, and then we have the constant times a function, all right? Rule. It says let k be a real number. If g prime of x exists, then the derivative of f of x equals k times g of x is f prime of x equals k times g prime of x. I'll give you an example for each one, okay? So the last example, we did the sum and difference rule. All it's saying is if you're given a function where it's a sum or difference of functions, let's say I got x squared, x cubed. Well, let me just say this. Let me say it's 2x cubed minus x squared. Okay? All right? What do I have here? The functions, right? So to take the derivative, so I can take the derivative of these functions, but I have to take one term at a time. How many terms do I have? I have 1, 2 terms. Okay? So I'm taking the derivative of each term one at a time. So what's the derivative of 2x cubed? Remember, you go 3 times 2 is what? 6. So I got f prime of x is equal to 6x. And then what do I do next? I subtract 1 from the exponent. Okay, what's 3 minus 1? 2. Okay? And then the derivative of x squared, right? I drop down the 2. Okay? So I drop down this 2 here. Right? And it's going to be minus 2x. Then I subtract 1 from the 2, and I get 1 here. And that's all you're doing, okay? And guess what? You see this power rule here? Well, that's what we were doing. We were using the power rule when we were taking the derivative of this function here. So I was using the power rule all this time right here, okay? So anytime I'm taking derivative of a sum and difference of functions, I'm going to be using the power rule. So the power rule was already embedded in what I did here, okay, to take the derivative. Okay, now constant times a function. All this is saying is, okay, let's say I have f prime of x is equal to 3x squared, right? Well, here's my constant. My constant is that, right? So when I take the derivative using the power rule, what am I going to do? I'm going to multiply the 2 times the constant, and right? Excuse me, it shouldn't be I'm not taking the derivative here. F prime of x. I multiply the exponent times the constant. What's 2 times 3? 6x, and then I subtract what? 1 from the exponent, and I get just 6x to the 1, right? But you don't have to put the 1. You just put 6x. So all this is saying is when you have a constant, when you're taking derivative, you already have a constant there already, you're going to multiply the exponent to that constant. That's all that rule is saying. And we've already been doing that. We already been doing that since with the last slide we just did, okay? That one problem that was given to us, that lengthy problem. We already been doing all these rules here. So now I'm just showing you what we did, okay? What rules that we use, okay? So this is a constant times a function rule, the power rule, and the sum and difference rule. I hope I'm clear. Okay, I hope I'm clear on what I'm teaching you, okay? It's hard to teach when you don't have students in the classroom. So this is challenging for me. So these are just different notations of taking a derivative, okay? All right? The notation that I use a lot is this one, okay? That's to say I took the derivative of a function. You can use all these, you can interchange these different notations when you take the derivative, okay? But the one that I use the most is f prime of x, this one, and this one. That's the one I use the most, okay? F prime of x dy. F prime of x means derivative of f of x, and dy dx means I'm taking the derivative of y with respect to x, okay? So these are just different notations of taking a derivative of a function, all right? Okay, and I'll interchange them from time to time so you can see what I'm doing. So here we go. Now this is a you try, but I'm going to do this when I actually teach this face-to-face. I actually let the students try on their own, but I'm going to do this with you. If I were you, I'd pause the video and try this one and see if you get it right, and then replay the video, and I will work it out. Okay, so right now, if I were you, pause the video, try it on your own, and then press play and see if you get the same answer as I do. Okay, so y prime is equal to, take the derivative of 3x of x cubed. That means it's going to be, the derivative of x cubed is going to be 3x squared minus the derivative of 16x squared. Well, 2 times 16 is negative 32x, okay? Plus the derivative of 45x is just 45. So anytime you're taking a derivative with a number and just an x, your answer is just going to be the number in front of that x, 45. And the derivative of the constant 5 is 0. It's just plus 0, okay? But I don't have to write that 0, so my final answer is just this, class. I don't have to write the 0, just that's my answer. Or you could have wrote it like this. You could have said f prime of x is equal to 3x squared minus 32x plus 45. Okay, I'm just showing you the different notations. Or you can go dy dx is equal to 3x squared minus 32x plus 45. I'm just illustrating what that last slide was telling us. You can use different notations. These different notations means derivative, okay? So that's your answer. That's how you take the derivative. And notice in this function, I'm adding and subtracting different functions here, okay? All right. So here's another example that can be kind of challenging, okay? In class, I actually picked problems that I saw in my math lab assignment, okay? So this is not just something I pull out of a book. These are a typical type of problems you will see on my math lab in your homework assignments. So here's example 2. Find the derivative. Well, notice your x values are all on the bottom, okay? I can't take the derivative with my x values on the bottom, so I need to take those things back on top. And the way you take those x values back to the top is you change the sign of your x. Since x cubed is positive, right? I got x to the positive cube, x to the positive squared, and x to the positive 1. This means 1, right? Okay, when I take those to the top, I'm going to change their sign. So therefore, I can rewrite this as y equals 2x to the negative 3 minus 3x to the negative 2 plus x to the 1 plus the square root of 2. See that? And now I can take the derivative of these functions. Now, but they're just negative exponents, okay? So then y prime is equal to, I don't know why I picked this color here. This color green is kind of hard to see. So what I do, I multiply negative 3 times 2, that's negative 6, x to the negative, okay, now let me change a different color here. Let me use black here. So I multiply that negative 3 times that 2, right? I get negative 6 x. Then I subtract 1 from the exponent. What's negative 3 minus 1? Negative 4, okay? Then I go negative 2 times negative 3, that's positive 6 x. I subtract 1 from the negative 2, I get negative 3. Then I go negative 1 times 7 is going to be minus 7x. I subtract 1 from the negative 1, I get a negative 2. And this square root of 2 is a constant. So if I take the derivative of this constant, it just goes to what? 0, right? So then my final answer, now watch this. Okay, watch how I write my final answer. Since I took, remember, those x values were on the bottom. Okay, and so when I took them to the top, they became negative. Now that I'm done taking the derivative, I cannot leave my function in negative exponent form, okay? Therefore, I got to take those values, those x values that are negative exponents, and take them back to the bottom. So I'm going to write negative 6 over x to the 4 plus 6 over x cubed minus 7 over x squared, and I don't have to write that 0. There is my answer. Okay? Again, class, if I'm going too fast for you, you can always re-watch this, pause it, write down the notes, replay it, okay? So just know you might want to watch this over a couple of times, okay, to get the grasp of it. All right? So that's how you take the derivative of this function. So if your x values with your exponents are in the denominator position, take them to the top by changing their sign, okay? And then take the derivative, and then after you take the derivative, if your exponents are still negative, then take it back down to the bottom. If you take the derivative and your exponents became a positive all of a sudden, then you don't have to take those to the bottom. Only negative exponents go back down to the bottom, okay? They're all negative exponents, so you put them back down to the bottom. That's your answer. Okay, clear. Now I'm going to go to the next problem. So these are just different examples that we can try here, okay? So you might want to pause the video and try these problems, all right? Try these problems. Pause the video, try them, and then replay it and see if you get the right answer. And once you replay it, I will work them out for you. Okay, so here we go. If I take the derivative of this, y prime is equal to 6x squared, that's going to be 12x. Negative 8x, derivative of negative 8x, just negative 8. And see that negative exponent here? The derivative of negative 10x to negative 2 is going to multiply to that negative 10. That's going to be a positive 20x, because a negative is a positive. Subtract 1 from the negative 2, and you're going to get negative 3. So then my final answer is y prime is equal to 12x minus 8. Now watch this. Plus 20. Since that x to negative 3 is a negative exponent, I just take it to the bottom. It's going to be x cubed. Okay? And that's my answer. All right? Okay. Now, look at this one. I got y equals 7x to the negative 2 minus 8x to the negative 1. Right? I take those to the top. Remember, that's a positive 1 here. So take the derivative. Y prime is equal to negative 2 times 7 is negative 14. The x, subtract the 1 from the negative 2, you get negative 3. Okay? Negative 1 times 8 is negative, it's positive 8, because you got a negative times a negative is a positive 8. X to the minus 1, which is equal to negative 2. I apologize for using the same color. I hope that's clear there, okay? So then now, I write my final answer as negative 14 over x to the cube, okay, plus 8 over x squared. And that's, I just take them back to the bottom because they're negative exponent. There's my answer. Okay? All right. So here I go. I'll promise I'll try to switch colors here. I'm going to rewrite this. So I got to change that to, I got to take that x to the top. Now, watch this. This is a cube root. Okay? A cube root of x. The way you change that to an exponent is, notice that the x has an exponent of what? 1 here. So I have negative 10 over, watch how I do this, x to the excuse me. So when you have cube roots and you change them to exponents, these exponents are fractions. So the 1, the x to the 1, that 1 there in red, that's the numerator of my fraction of my exponent. And see the 3 on the outside, that's my denominator of my exponent. Okay? So it's negative 10 over x to the 1/3. That's how you change cube roots or square roots into their exponents. Okay? The exponent on the inside goes on the top. The exponent on the outside goes on the bottom. So then now I can take it to the top. Y equals negative 10 x to the negative 1/3. I'm going to change colors here. Okay? All right, so back to black. So therefore, what am I going to do? I'm going to multiply the negative 1/3 times negative 10. That's going to be y equals, a negative times a negative is a positive. That's positive 10 thirds to the x, subtract 1 from negative 1/3. Well, negative 1/3 minus 1 is going to be negative 4 thirds. Okay? And so now I'm done taking the derivative. All right? Well, I don't have to write that there. Okay? Let me erase that. Okay. All right. So I take that exponent back to the bottom. Watch how I do this, okay? Now that 3 is already on the bottom, so it's just x to the what? 4/3. Now, remember, in the beginning, it was in the radical form. It was in square root form. I've got to change that fraction back to a square root form. Remember, the number on top is the exponent on the inside, and the number on the bottom, the 3, is the number on the outside. So when you rewrite this, you go y equals 10 divided by 3, okay, times the, because it's going to be x to the what? 4, and this is a cube, okay? So cube root of x to the 4, and that's your answer. Okay, there's one thing I'm concerned about this one, okay? I don't remember how my math lab is going to want the answer, but going back to the first one here. You see how the x cube is on the bottom here? You might have to, I might be wrong, but you might have to, you know, make it a common denominator for all of these, for this whole function. So in other words, what's my common denominator? X cubed. That means the 12x needs a common denominator. 12x needs a common denominator of x cubed. And negative 8 also needs a common denominator of x cubed. So I might have to do this, class. I might have to rewrite this where the whole thing has a common denominator of x cubed. So therefore, how do you do that? Well, you multiply 12x times x cubed, and you divide it by x cubed. And you multiply negative 8 times x cubed, and you divide by x cubed, and plus 20 over x cubed. Okay? So there my final answer would be probably be, well, 12x times x cubed is 12x to the fourth. Negative 8 times x cubed is negative 8x cubed plus 20, all divided by x to the cube. You see what I mean? So they might want their answer in this form. Okay? So just double check on that. Make sure you put it in the right form in my math lab. Okay? So let's go on to the next slide. Okay. So the question is, how would you do these two? How would you do these two? Find the derivative of the function. Okay. Well, the way I would do this one is, number one, I can't have that x squared in the bottom, so I got to take it to the top. So y equals, watch how I do this, x to the negative 2. But see this x to the fourth plus 5, put that in parentheses. Because now it went from x squared dividing x to the 4 plus 5 to multiplying x to the 4 plus 5, but it's a negative exponent, right? Okay, so then now I distribute that negative x squared into the parentheses. So that's going to give me x to the negative x squared times x to the 4 is x to the squared. Remember, when you multiply, you add the exponents. So what's negative 2 plus 4? Negative 2, okay? Let me use a different color here. I keep doing this. I need to make sure that you understand what I'm doing, okay? So that's x to the 2. So when you multiply, you add the exponents. So negative 2 plus 4 gives me positive 2 here, okay? All right? Plus x to the negative 2 times 5 is 5x to the negative 2. See, now it makes it easy to take the derivative of this thing. So y prime is equal to, the derivative of x squared is just 2 times x. The derivative of 5x to the negative 2, well, that's going to be negative 2 times 5 is going to be negative 10x. Then I subtract the 1 from the negative 2, that's negative 3. Right? And then what do I do with that x to the negative 3? I take it back down to the bottom. So y prime is equal to 2x minus 10 over x to the 3. But again, they might want you to find the common denominator of this function here, okay? Which your answer would be this. Y prime is equal to 2x to the 4 minus 10 over x to the 3, okay? They might want your answer like that, or they might want your answer like this, okay? And remember, the way I got that is I have to find the common denominator, so I multiply the top and the bottom by x cubed. Just in case you don't know where I got that answer. I multiply the top and the bottom by x cubed, and multiply this by x cubed. And you know that 2x times x cubed is 2x to the 4, okay? All right, so that's how you might have to write your answer. Okay, now I'm going to do this one. Now this one, what you're going to have to do is x to the 5th minus 2 is the same thing as saying x to the 5th minus 2 times x to the 5th minus 2 times x to the 5th minus 2. Means you got to multiply it times it. Okay? Oh, okay, so here we go. By doing that, I got x to the 5th times x to the 5th is x to the 10. Remember, when you multiply, you add the exponents. X to the 5th times negative 2 is negative 2x to the 5th. Okay? Negative 2 times x to the 5th is negative 2x to the 5th. And negative 2 times negative 2 is positive 4. All multiplied to x to the 5th minus 2. Okay? And then now you got to multiply all of this times this, right? So I'm going to go x to the 10 times x to the 5th. That's going to be x. Remember, you multiply, you add. 10 plus 5 is x to the 15. Negative 2x to the 5th times x to the 5th is negative 2x to the 10. Negative 2x to the 5th times negative 2 is negative 4x to the 5th. Okay? And negative 2x to the 5. What am I doing? Wait a second, class. Wait a second. No, we don't do that. No, we don't do that. Hold on just a second. Okay. Okay, I shouldn't have multiplied that negative 2x to the 5th to the negative 2. Okay? I should just keep multiplying that negative 2x to the 5th to the x to the 5th. Okay? So negative 2 x to the 5th times x to the 5th is negative. Why did I do this? I don't know why I did it this way. Negative 2x to the 5th is negative 2x to the 10 again. And then 4 times x to the 5th is plus 4x to the 5th. Okay? So you got that, right? And then now we do the same thing, but we multiply everything to the negative 2. So x to the 10 times negative 2 is negative 2 is negative 2x to the 10. Okay? And negative 2x to the 5th times negative 2 is going to be positive 4x to the 5th. And negative 10x to 5th times negative 2 is the same thing, positive 4x to the 5th. And 4 times negative 2 is negative 8. And then you combine all your like terms. Okay? So you combine all your like terms. So this is going to be x to the 15. Okay? Now, negative 10, negative 2x to the 10 minus negative 2x to the 10 minus 2 negative x to the 10. These are like terms here, right? That's going to give me negative 6 x to the 10. Okay? So I combined those. I'm going to cancel them out because I combined those. I already wrote this down, so I combined those. Now I got 3 4x to the 5th. So 4x to the 5th plus 4x to the 5th plus 4x to the 5th is going to be plus 12x to the 5th. So I combine all those. Minus 8. Now I can take the derivative. So you got to do all that. Now later on I'm going to show you a shortcut to all this. But right now they don't teach you this in this section here. So now I take the derivative and I'm done, okay? So the derivative, okay, what's the derivative of, no, that's not a good color. Just use the blue. So what's the derivative of x to the 15, which is going to be 15 x to the 14 minus the derivative of 6x to the 10 is going to be negative 60 x to the 9. The derivative of 12x to the 5th is going to be plus 60 x to the 4th. And remember, the derivative of a constant is 0, so this is so I don't have to write that 0 down. So the derivative of negative 8 is 0. I don't have to write that down. That's my answer. That's my derivative. Okay? You might want to pause it, redo this problem again, and see if you make sure you understand it. So here's just an overview of what we've been doing. Okay? It's just a chart of doing the power rule. So anytime I have a term, derivative of x is just 1. Right? The derivative of x is just 1. The derivative of x squared is 2x. The derivative of x3 is 3x squared. Right? The derivative of x to the 4 is 4x cubed. Because why? Because we take the exponents. I'm going to have to show this with a different color. You take the exponent and put it to the front and subtract 1 from the 2. Right? You take the 3, drop it to the front, subtract 1 from the 3. You take the 4, drop it to the front, subtract 1 from the 4. Okay? If f of x is x to the negative, take your negative 1 and subtract 1 from negative 1, and you're going to get this, right? Negative 1 x to the negative 2. And because you have a negative exponent, you take it back to the bottom, and you get this, right? If your exponent is a fraction, you do the same thing. You take your fraction, drop it to the front, and you get 1/2. Subtract 1 from the fraction. Well, 1/2 minus 1 is negative 1/2. You get the negative 1/2. And you take that negative 1/2 to the bottom, and you get 1 over 2 to the x to the 1/2. Now, in the book here, they left it as x to the 1/2, but it depends on what my lab wants, my math lab wants. They might be okay with that answer there, or they might want you to put it back in radical form. Well, it wasn't even radical form in the beginning, so that's your answer. Okay, never mind. That will be your answer. Okay? All right. Okay, so here's some type of problems you'll see on my math lab. It says, which of the following describes the derivative of f prime of x of a quadratic function? Okay? Well, what is a quadratic function? All right? Well, the simplest quadratic function is x squared. Any x to the squared is a quadratic. Any equation that has an x squared in it, and where x squared is the highest power, is a quadratic function. So if I were to take the derivative of that, what's the derivative of a quadratic function? You're going to get 2x, right? Because I drop that 2 to the front. I subtract the 1 from the 2, I get 2x. Well, what kind of function do I have here? Well, look at the degree of the exponent. It's a what? 1. That means the function that I got is a linear function. So my answer is linear. So what is this telling me? This is telling me anytime I take the derivative of a quadratic function, I'm going to always get back a linear function. Okay? Anytime I take the derivative of a quadratic function, I'm always going to get back a linear function. Okay? So that's what they're asking for there in that problem. Okay? And here's another problem here. It says, explain the relationship between the slope and the derivative at x equals a. Explain the relationship between the slope and the derivative of f of x at x equals a. Okay? So, when you're finding the derivative, you're finding the slope of every point of the function. Okay? So, anytime you're finding the derivative of a function, you're finding another function that will give you the slope of every point of your original function. Okay? So my answer to that is, all right? Let's see here. Is going to be, your answer is C. Okay? The derivative of f of x at x equals a equals the slope of the function at x equals a. Okay? All right? Okay. I don't know if that makes sense to you or not. Okay? So, I guess I'll explain it with this example here. All right, so watch. Here's example 6. Okay. So, find the derivative of negative 3 if f of x is equal to x to the 4 over 7 minus 7x. So, first thing I need to do is find the derivative of my function. Well, f of x is equal to x to the 4 over 7 minus 7x. The first thing I do before I take the derivative of when they got fraction numbers that are fractions here is I move that fraction to the side. So like that 7, that's the same thing as 1 over 7 x to the 4 minus 7x. That's what I do with those fractions. Let's move to the side. And now I can take the derivative. So f prime of x is equal to, you take the 4, multiply it to the 1 over 7, that's 4 over 7, x. Let's subtract 1 from 4, you get x cubed. Right? Then derivative of negative 7 minus 7. So there's my derivative. Okay? Now, what is it that they want me to do? They want me to find the derivative they want me to find a derivative. Let me write a different color here. They want me to find the derivative of x at x equals negative 3. So they want me to plug in negative 3 into that function. So f prime of negative 3, plug that negative 3 into your derivative function. Plug it in here. Okay? So it's going to be 4 over 7 times negative 3 cubed minus 7. Okay? Well, that's going to give me 4 over 7 times negative 27 minus 7. All right? And so then I got to figure all that out. Now, I don't have a calculator on me, so I'm going to have to do this by hand. So 4 times negative 27. Well, what is 4 times negative 27? Well, negative 27. I'm going to go to the side here. So negative 27 times negative 4. That's going to give me 16. 2 times 4 is 8, plus 1 is 9, 96. So it's going to give me a negative 96. I don't know why I put these negatives here. I know it's going to be a negative 96, right? So you're going to have negative 96 over 7 minus 7. Now, I'm going to go ahead and divide. What is negative 96 divided by 7? So negative 96 divided by 7. Well, 7 will go into 9 one time. It's going to be 7. I don't have to put that negative there, okay? So that's going to be 9 minus 7 is 2. That's 26. Well, what number times 26 gives me 7? How many times will 7 go into 26? 3 times 7 is 21. 26 minus 21 is what? 5. So therefore, your answer is 13 and 5 over 7, okay? All right, so anyway, I don't get a whole number. So therefore, what we'll just do then is this. We'll just go ahead and say, okay, negative 9 over 6 over 7 minus, let me just leave it as, let me just ignore what I just did here, because I didn't get a whole number. And if I want to subtract 7 from 96 over 7, I've got to find a common denominator. So I multiply negative 7 by 7 over 7, right? And I don't need this negative here. So it's going to give me negative 96. Guys, I apologize for all these errors here. Oh, I erased the whole thing. So I get it back here. Yeah, there, get it back. Okay. So, erase this. Okay. So, ignore everything that I did here, this dividing stuff. Just ignore it. I was hoping I could get a whole number, but I'm not. I'm getting a decimal here. I'm going to get a decimal as an answer. Okay? And that's fine. There's nothing wrong with decimals. It's just... So you're going to get negative 96 over 7 minus 49 over 7. And what do I get? Negative 96 minus 49, that's going to give me 6 plus 9 is 15. Carry the 1. 9 plus 4 is 13, plus that extra 1 that I carried over is going to be 14. So it's going to be negative 145. Okay, over 7. What did I just find? I found the slope, okay? I found the slope at x equals negative 3, okay? Which is negative 145 over 7. I don't have a calculator on me to get the decimal of that. But let me kind of show you what's going on, class, okay? I'm going to graph this thing using Desmos calculator, okay? It's a free calculator that's online just to show you what you're finding. What is a derivative? What's the whole purpose of a derivative? The derivative is to help you find the slope at every point on your function, okay? So I'm going to go to this Desmos calculator here. Okay, and I'm going to plug in that original function, okay, so it's going to be x to the 4 divided by, divided by 7, okay, minus 7x. Okay, so there's my, see what I found? This is my graph, right? Okay, I remember I took the derivative of this thing, correct? When I took the derivative of this thing, I found another function that helps me to find the slope at the point. What point am I looking at? I'm looking at negative 3. Where is negative 3? Okay, well, negative 3 is right here, I believe. So this negative 3 is right. Okay, let me do this. Negative 3 is this. Clear the screen here. I apologize. Negative 3 is this point right. I believe it's this point here. Okay? So I'm going to follow this line here. All right? I'm going to follow that line all the way up. Okay? So it's this. Let me see here. You can't see that here. So it's this point. Okay. It's this point right here, I believe, okay? There's negative 3 right here. Let me see if I can just go. Okay, I'm over here messing things up. Let me scroll more into it, okay, so you can see it yourself. Okay? If I follow the point, I'm trying to get to negative 3. See the x value there? It's at negative 2. Okay? Going up, going up, going up. Okay. There it is. See negative 3? Okay. There's negative 3, right? Okay, I'm trying to be perfect here. There it is, right there. Okay. What you're finding is, I wish it would stay there, that dot. It's not going to do it. Okay, right there. Right there. Let me just say it this way. It's negative 3 is about, I can't even remember where I had it. It's about right here somewhere, right? Okay, here's negative 3. Okay. What you're finding, class, is you found the slope of the line that goes through that point. I'm not doing a good job here. See what you found when you took the derivative of the function, okay, this big red function, this red graph, you took the derivative of that function's graph, right? The graph of that function, and you got another function, right? Well, what you found was the slope of the slope at that point, and the slope at that point of a line that goes through that point. The line that goes through that point, that's tangent to that point, is going to be that number that we got, which is what? Hope this is clear. Okay, I already erased it. Okay? All right. I can't remember the number, class. I erased the whole thing. But it was negative, yeah, it was 145. The slope was what? 145. I can't even write. Over 7. So what you did was you found the slope at that point. The line that goes through that point or touches that point. See, that's a better line there. Okay? The slope of a line that goes through that point, it's called the tangent line, is 145 over 7. That's what you found at x equals 3. Okay? So this point is at x equals 3. Okay? And at x equals 3, the slope is 145 over 7. That's what you found, class. All right? I'm doing my best to show you that. I'm not doing a good job with what I'm doing, but I hope that's clear. As you study this, okay, you'll catch it. Okay, you'll catch on what I'm saying. All right? So that's what we found. Okay? All right. So all you're doing is, okay, I'm not going to do these. Okay, I'm not going to do those two. All right? It's the same thing what I just did earlier. You take the derivative and then you plug the 25 into the x and you're finding the what? The slope of the tangent line of the graph, okay? All right? So, well, I'll tell you what. No, I got to do this one. So watch this one, okay? Let me do both of them. So, find the slope of the tangent line to the graph of the given function at the value of x. So what you do is the derivative, y prime is equal to 1/2 times 9 is 9/2 x to the 1/2 minus 1. Okay? Plus derivative of x to the 3/2 is 3/2 x to the 3/2 minus 1. And then let's go ahead and clean that up. So it's going to be 9/2 x. What's 1/2 minus 1? Well, it's negative 1/2. Okay? Plus 3/2. What's 3 minus 1? Well, that's going to be 1/2. Okay? X to the 1/2. All right? Okay. So then now what I need to do then is that x to negative 1/2 needs to go down to the bottom. So I got y is equal to 9 to the 2 times x to the 1/2 plus 3, okay, times x to the 1/2 divided by 2. Well, guys, x to the 1/2 is the same thing as saying square root of x. Okay, x to the 1/2 is equal to the square root of x. Remember, this 1 is the one that goes here, and this 2 is the 2 that goes here. But we never write the 2 when we say square root. We just say this. Okay? We just say square root of x. So therefore, I can rewrite this as y equals 9 over 2 times the square root of x plus 3 times the square root of x over 2. So all we got to do is plug in that 25 into x, right? So we got y equals 9 over 2 times the square root of 25 plus 3 times the square root of 25 over 2. Well, what's the square root of 25? The square root of 25 is equal to 5, right? So therefore, I can rewrite this as y is equal to 9 over 2 times 5, because the square root of 25 is 5, plus 3 times 5 over 2. Okay, so that's y equals 9 over 10 plus 15 over 2. Okay, and then that's going to give me the answer. All right, so 9/10 plus 15 over 2. Oh, what is that? What's 9/10 plus 15 over 2? Well, I'm going to get a calculator out of here. So 9, okay, divided by 2 is what? 4.5. Okay, so I know that 9/10 is 4.5, so this is going to be 4.5. Wait a second. I said 9 divided by 2. Excuse me. Okay, clear. 9 divided by 10 is 0.9, not 4.5, okay? So 0.9, let me clear this here. Oh, let's see here. It's not doing a good job with this calculation here. So it's going to be 0.9 plus 15/2 is 7.5. I should know that, right? Okay. And what is that? What is 0.9 plus 7.5? Okay. Well, I'm running out of room over here, so let me just write it over here. That's going to be, okay, that's going to be 8.4. Okay. So this is going to be 8.4 is the slope. That's your answer for letter A. Get that calculator out of the way. So y'all see what I did? That's what you found. All right? Okay. So your answer to letter A is 8.4. Find the slope of the tangent line to the graph of the given function. The slope is 8.4. Okay? Now let me do letter B. And I'm almost done with this lecture here, okay? All right. I'm going to do orange here. Now letter B. I'm going to need all the room I can get here. Well, I can't do orange. I guess I'll do red here. Let me clear the screen. Okay. So, I'm going to need all the room I can get, guys. So I'm going to start letter B up in this area right here. So first thing I got to do is find the slope and the equation of the tangent line. This is why I want to do these videos, so you can see what we're doing, okay? And again, there's some videos that the book gives you online as well. There's other videos that the author of the book has done, okay, that are on MyLab that you can click on, okay? So find the slope of the equation of the tangent line to the graph of the function at the given value of x. All right, so take the derivative of f of x. I should start up here. F prime of x is equal to the derivative of x to the 4 is 4x cubed. The derivative of negative 13x squared is negative 26x. And the derivative of 36 is just 0. So erase this. So there's a derivative of f of x, right? Okay. Now you plug in 1. So you plug in 1 into the function. 4 over 1 cubed minus 26 times what? 1. Okay. Well, 1 to the cube is 1. What's 4 times 1? 4. And 26 times 1 is minus 26. So what's 4 minus 26? Well, that's negative 22. See what I found? I found the what? Slope. Okay, at x equals 1. Okay, I found the slope. Now they want me to find the equation of the tangent line. Well, it's real simple. I don't know if you remember in algebra, there's this formula called the point slope formula. And it looks like this. Y minus y1 is equal to m times x minus x1. Okay? Well, we know the slope. Let me write it over here because we know the slope, the m, okay, is equal to negative 22. We know, now we're going to call this x here. See that x equals 1? We're going to call that our x1, okay? All right? So we're going to plug this in. So we know our x1 is equal to 1. What we don't know is y1. How do we find y1? Well, all you got to do to find y1 is just plug the 1, right, into this function here, into your original function. Okay, so y1 is equal to f of 1, which is equal to 1 to the 4th minus 13 times 1 squared plus 36. And if you do all that calculation right, you're going to get 1 minus 13 is negative 12, and negative 12 plus 36 is going to be negative 12 plus 36 is going to be 24. Okay? Negative 12 plus 36 is going to be 24. All right? So 24 plus 12 gives me back 36. So there is my y1. So to find your y1, you just plug in the x value that they give you, 1, back into the original to get your y1. And then now I just plug those values into the equation. So y minus y1, which is 24, is equal to m, which is negative 22, times x minus x1, minus 1. And that might be your answer. That might be all you have to write. This could be your answer. But they might want to go a step further. Okay? So this right here could be your answer. You could just probably circle this and go on. But my MyLab might want you to change it. Might want you to put it in y equals mx plus b form. Okay? Remember the y equals mx plus b form? Okay? So they might want you to change this into the y equals mx plus b form. Well, that's not hard. Just distribute the negative 22 into the parentheses, and you're going to get y minus 24 is equal to negative 22x plus 22. Then add 24 on both sides. And your answer is y equals negative 22x plus 46. And that is an answer, or they just might want this as your answer. Okay, either or. All right? I hope that helps you. I'll try to do a better job next time making a lecture. This is the first time you're doing it for an online class. I hope that helps you. Okay, let me go on to the next example here, and I'm done. Let me do this last one before I call it quits. Okay, so here's the last example. It says find all the values of x where the tangent line is horizontal. So find the x values where the tangent line is horizontal. You know what that means? where the tangent line is horizontal, that means where the slope is equal to 0. Find all the x values where the slope is equal to 0. Well, how do you find the slope? You have to take the derivative of the function, right? So the derivative of this function is going to be 6x squared plus 39 times 2. That's going to be 2 times 9 is 18. Carry the 1. 6 plus 1 is 78. Okay. X. The derivative of 216x is 216. And the derivative of 10 is 0. So there's my derivative, right? Well, okay, so when it says find the x values, the values of x where the tangent line is horizontal, it's saying find the x values where the slope of your line is 0. The slope of your tangent line is 0. That's what it means by horizontal. Your slope of your tangent line is 0, okay? So how do you do that? Well, they give us the x value, and we plug the x value in to get the slope. Now, they gave us the slope in a sense, right? Okay, you just have to know that horizontal means m equals 0. And now you're just working backwards. You take your derivative function, and you already know that, hey, my slope, my derivative function, is 0. Because remember, the derivative helps me find the slope. So if the derivative helps me find the slope, but the derivative equals to the slope, then that means I set my derivative function equal to 0 and solve for x. Well, how do you do that? Well, you have to factor, okay? So the first thing I want to do is I can remove a 6 out of here, okay? X squared. I can factor out a 6. Okay? Now, okay, so let's go back to the calculator here. Okay? And so, let's do this real quick. So what is, okay, 178 divided by 6, okay? So we know that 178, okay, divided by 6 is equal to, okay, I'm not giving a good number here. Can I no, excuse me, I said 178. Excuse me, 78. 78 divided by 6. It's 13. Okay, so I know that I'm going to get so it's going to be 6x squared, okay, plus 13x, right? And now, what's 216 divided by 6? So 216 divided by 6 is equal to 36, okay? So therefore, I'm going to get plus 36 is equal to 0, okay? So I factor out the 6, and I got this. Now I can factor this part. Now this is something you should already know how to do, okay? But what numbers, this is how you do it. So we'll just take this out, ignore the 6 for right now, because we don't need it, okay? What numbers multiply to give me 36, but add to give me 13? Well, come to the side here, find your multiples of 36. Well, 6 times 6 gives me 36. Negative 6 times negative 6 gives me 36. Oh, 4 times 9 gives me 36. And negative 4 times negative 9 gives me 36, right? But which one of these adds to give me 13? Well, 6 plus 6 gives me 12, so that doesn't work. Negative 6 minus 6 gives me negative 12. That doesn't work. But 4 plus 9 gives me 13. That works. And negative 4 minus 9 gives me negative 13. That doesn't work. So my factors are 4 plus 9. So all you have to do now is make 2 parentheses with an x in each one. One of them is what? 4, positive 4, and the other one's positive 9. And that 6 here that you factor in, you just drop. This is still equal to what? 0. But still, we don't need that 6. I'm just going to drop it there so you know that so that way you don't think I made an error, all right? But we're not going to use that 6 anyway. So now that I factor it, now I can solve for x. Well, what does it say here? 6 times x plus 4 times x plus 9 equals 0. What does that mean? That means x plus 4 could be 0, right? Or x plus 9 could be 0. Because what's 0 times 0? 0, right? Or what's 6 times 0 times 0? 0. So therefore, all I do is take those equations in parentheses, x plus 4 equal to 0. Take the other one, x plus 9 equal to 0, and solve for x. So I subtract 4, x is equal to 4, I subtract 9, x is equal to 9. So these are the x values. At those x values, my slope is horizontal, or my tangent line is horizontal, which means at those x values, my slope is 0. Okay, and those are my answers, 4 and 9. Okay, all right. I'm done. That's it for the lesson. I hope this helps you. Please email me if you have any questions on anything. Okay, I'll be glad to help you. All right, class? Don't quit. Do the best you can. I know you can do this. Thank you.